Welcome back. Here we learn about the physical properties of soil. Physical properties of soil is divided into four groups: soil texture, soil structure, soil color, and bulk density. Soil bulk density. In the previous presentation, we learned about the soil mineral, that is about 45% of the total soil. Soil mineral contains sand, silt, and clay. And sand, silt, and clay determines the soil texture. The proportion of or the percentage of sand, silt, and clay within a soil system determines the soil texture. If the sand particle is more, the soil is more like a sandy soil. If the silt particle is more, the soil is more like a silt soil. And if the clay particle is more, the soil is more likely a clay soil. And sand, silt, and clay is the same material, but only the size is different. They all are derived from the parent materials, or these all are formed by the process of weathering of rocks. The only difference is the size of the particle. If the size is big, then that is sand. Medium size, silt. Very fine size, clay. We can see this more clearly here. The big one is the sand particle. And when the sand particle is chopped or broken down into the small size like this, then this is the silt. The size is given here. And when the silt converts to the very fine particle, that is called clay. And according to the size of the particle, the color also can be different: clay, sand, and silt. Then how do we determine the soil texture? Let's see an example. If the soil sample contains sand 50%, silt 20%, and clay 30%, what is the texture of the soil? To find out the texture of the soil, once we know the sand, silt, and clay percentage, we use the USDA textural triangle. Here is it. So the sand is 50%. That means sand is 50%. We find the 50 and draw a line all the way next to the next side of the triangle. Then silt is 20%. Find 20 silt here and draw the line all the way to the next side. We already know the texture of the soil. To make the verification, use the 30 clay. Clay 30. So our soil texture is sandy clay loam. This is how we can determine the texture of the soil using the soil textural triangle. And there is another method, if you remember, the feel method. You form a ribbon between your index finger and thumb and try to identify the soil texture. This is more like a lab method. In the lab, we determine the sand, silt, and clay percentage. And once the sand, silt, and clay percentage are determined in the lab, probably you did a sedimentation method in the lab. Then once we know the sand, silt, and clay, we can use this textural triangle and find out the texture of the soil. Then soils have different structures: granular, bulky, prismatic, columnar, platy, and single grinded. This is all about how the soil is looking like, how the soil behave. It determines the soil structure. And there are a couple of factors that affect the soil structure: type of soil, amount of organic matter, freezing and thawing, wetting and drying, action of burrowing organisms, and growth of the root system of the plants. These factors may affect the soil structure. Next one is the bulk density. The equation of density is mass divided by volume. And bulk density is not too much different. It is the weight of the oven dry soil divided by the total volume of the soil, where the weight is measured in grams and volume is measured in cubic centimeters. Therefore, 10 gram per cm cube, 20 grams per cm cube, 40 grams per cm cube. That is how the bulk density will be looking like. But bulk density generally does not go like 30, 40, 10 and so on. The ideal bulk density for soil is 1.33 gram per cm cube. Again, 1.33 gram per cm cube is the normal or ideal soil bulk density. When the bulk density is too high, for example 1.6, the number does not sound like a very big number, but 1.6 is a very high bulk density. Once the bulk density is very high, then the plants will have a hard time to penetrate the soil, or plant roots will have a hard time to penetrate the soil. And also when the bulk density is high, it affects the water infiltration. That means the soil is pretty compacted. The compacted soil will have high bulk density. Therefore, it affects the water infiltration and root growth. It means the variation in bulk density is due largely to the difference in the total pore space. Once the soil is compacted, the total pore space will be reduced. So, bulk density will be high. And if the soil is too much loose, then the bulk density can be low because there is a lot of pore space and soil is not compacted. Effect of bulk density, it affects the engineering properties because we establish engineering structures into our soil system, or soil holds so many things, roads, buildings and other structures. Therefore, the bulk density of soil is important in engineering. Water movement, as I told you, if the bulk density is too high, then there would be a problem in water movement, especially water infiltration would be reduced. Then I told you about the rooting depth of plants. High bulk density, low penetration. The plant roots cannot go all the way down to the soil profile where they need to be. And once the roots are not growing well, you know that it affects the growth and development of the plants. In dry areas, we'll learn about the soils in dry areas in the next lecture. In the dry areas, we want to make sure that the roots can go deeper and deeper to the soil profile so that they can extract water from the deeper soil layer. Here you can see the bulk density is 1. The soil looks pretty loose because we have a lot of air space, and here the soil is compacted and the bulk density is already 1.4. Lower bulk density, higher bulk density. Again, lower means about 1, 1.2, higher means 1.6, 1.7, and medium or the normal bulk density is 1.33 gram per cm cube, cubic centimeter. In this table here, you can see the soil texture, different soil texture, and how the bulk density will be looking like. If the soil is sandy, the ideal bulk density is 1.6. Sandy loam, 1.4. Sandy clay, 1.4. Silt, 1.4. Silt loam, 1.4. Sandy clays, 1.1. Clay, 1.1. These are the different values, but as a whole, as I told you before, the normal soil will have about 1.33 gram per cm cube. 1.6 is already high, but this is the sandy soil.